Hi class, today we're going to talk about section 6.5a, and it is called Operations with Radical Expressions. So what we're going to do today is learn how to simplify radicals. And these are complicated. I wish I could be more positive and say that they weren't, but they are a little complicated. They will take practice. You will see a little bit of them in college algebra, so we're just going to look at a little bit of them on the next two lessons. So today we'll just be looking at simplifying the radicals. Tomorrow we'll be looking at adding, subtracting, multiplying, and dividing the radicals. So you've got a couple of properties here. The product property of radicals just states that for any real numbers a and b, and any integer n that is greater than 1, that you can take the nth root of ab and rewrite it as the nth root of a times the nth root of b. This makes it easier to simplify, and we will use this product property as we work through these. When you're working with square roots, to simplify a square root, you factor the radicand, what's underneath, into as many squares as possible. Then use the product property to isolate the perfect squares, and that will enable you to simplify each radical. The quotient property is similar to the product property in that you can break it apart. So this says basically the same thing for any real numbers a and b not equal to 0, because you can't have a 0 in the denominator, and any integer n greater than 1, then the nth root of a divided by b is equivalent to the nth root of a divided by the nth root of b. Now, you're going to end up with radicals in the denominator, and we are going to do what's called rationalizing the denominator to get rid of the radical in the denominator. We can't have a radical in the denominator. So we multiply the numerator and the denominator by a quantity so that the radicand has an exact root. Now that is going to be hard for me to sit here and explain without showing you when we get to those examples. So that's what I will do. All right, so let's get started with a few examples. So to start with, we're going to simplify these radicands. Okay, so you want to look at, you've got a 5 outside of here. I'm going to rewrite that. And then I'm going to think of the highest number squared that goes in to 54. And if you wanted to, you could break down 54 like so. You could prime factor it. 2, 27, 3, and 9, and 3, and 3. So if you can see from here, you can make 3 squared, and then these aren't, you can't do anything other than multiply those together, and that would be square root of 6. Now, y'all have learned these before, that when you're simplifying the radicals, that if it's square root, you're dividing by 2. So this gets divided by 2, meaning we would have 5 times 3, but we can't do anything with the square root of 6. So our answer will be 15 square root of 6. So let's try the same thing with a number 2 and the number or example 2 and the number 75. Let's break it down into the product of primes and see where we have some squares, okay, since we're taking the square root. So 75 is not divisible by 2, but it is by 3, and it goes in 25 times. And I can break 25 down into 5 times 5. Notice that's 5 squared. So we can rewrite this as the square root of 5 squared times the square root of 3, because that's what we have left, times the square root of x to the 4th. Since I can divide the power, since I can divide 4 by 2, I don't have to break this down at all. Y to the 7th, though, I'm going to rewrite that as the square root of y to the 6th times the square root of y. That is the square root of y to the 7th, but this is the largest even number that we can pull out because we're dividing by 2. So when we divide by 2 here, that gets rid of our radical and would leave us with a 5. When we divide by 2 here, we'd be left with x squared. When we divide by 2 here, we'd be left with y to the 3rd. And then the rest stays underneath the radical, so 3y. That would be our answer. Now we're moving to the 3rd root. So we want to get powers of 3 instead of powers of 2. We want powers of 3 that we can pull out. So let's take negative 16, or just take 16 to start with. It's divisible by 2. 8's divisible by 2. 4's divisible by 2. If you can see, we've got 2 to the 3rd times 2. And we can make that, then we can make it negative, because a negative times a negative times a negative is a negative. So I'm going to rewrite this as the cubed root of negative 2 to the 3rd, negative 2 to the 3rd, the cubed root of 2, the cubed root of a to the 3rd times the cubed root of a squared. I'm running out of room, but I'll write down here the cubed root of b to the 6th and the cubed root of b. So I broke these down, the variables down, into powers that were divisible by 3. So if I had a to the 5th, then I could take an a to the 3rd and an a squared. And if I had a b to the 6th, or b to the 7th, I could take b to the 6th and b. So when I simplify, I'm dividing my powers by 3. So 3 divided by 3 would give me a negative 2. So I'm going to mark it off since we cleaned it up. A to the 3rd divided by 3 would be a. B to the 6th divided by 3 would be b squared. And then we'll be left with the cubed root of 2a squared b. Okay, on example 4, this time we're looking for the 4th root, so we want to raise, we want to have an exponent of 4. So we'll take our 32, divide it by 2 would be 2 and 16. Divide 16 by 2 would be 2 and 8. Divide 8 by 2 would be 2 and 4. And divide 4 by 2, which would be 2 and 2. So you can see we've got 1, 2, 3, 4, 5. So we can take 2 to the 4th times 2. So we're going to have the 4th root of 2 to the 4th times the 4th root of 2 times the 4th root of a to the 8th times the 4th root of a. That'll give us a to the 9th. And then times the 4th root of b to the 20th. So we'll divide the powers by 4 to get the 4th root. This would leave us with a 2, so I'm going to mark him off. This would leave us with an a squared, so let's mark it off. This would leave us with a b to the 5th. So we'll mark it off. And then all we have left underneath the radical would be the fourth root of 2a. So its actual answer is 2a squared b to the fourth times the fourth root of 2a. Okay. Now let's try the next four. These involve quotients. So what we want to do is we want to set them up separately. Square root of 36 over the square root of 125. Well, hopefully you know that the square root of 36 is 6. The square root of 125, if we want to break it down, 125 is divisible by 5 and 25, and 25 is divisible by 5 and 5. So we would have a 5 squared and a 5 on the bottom. So square root of 5 squared times square root of 5. Now, the square root of 5 squared is going to be 5. So our next step would be to write this as 6 over 5 times the square root of 5. And then when it's said to rationalize the denominator or to get rid of the radicals, what you would do is if it's square root, then it would take 2 of these to get rid of the radicals. So I'm going to multiply the numerator and the denominator both by the square root of 5. So what that's going to leave us with, and the numerator is 6 square root of 5, and on the bottom will leave us with 5 times 5, because the square root of 5 times the square root of 5 is 5, and 5 times 5 is 25. So 6 square root of 5 over 25. Okay, on number 6, we're doing square roots, so we want to break apart our numerator and our denominator. So we're going to have a to the 6th. We're going to have the square root of b squared, square root of b, over, hopefully that you know that 49 goes into 98, so we could take the square root of 49 times the square root of 2. Now we're dividing our powers by 2, so next step would be to have a to the third b square root of b over 7 square root of 2. Now to get rid of the square root of something, I need 2 of them, so I'm going to take and multiply by the square root of 2 on the top and on the bottom, square root of 2. So my numerator will be a to the third b square root of 2b, and on the bottom I'll have 7 times 2, so I'll have 14. Okay, last 2 of these. Let's take the numerator and rewrite it, and how about if I rewrite it as the square root of 4 times the square root of 2 times the square root of x squared times the square root of x over the square root of 9 times the square root of 5 times the square root of y to the 4th times the square root of y. So my numerator would simplify to 2, then x squared divided by 2 would be an x. So then I would have 2x square root of 2x. In the denominator I would have 3y squared, because I'm dividing 4 by 2, square root of 5y. Now I need to multiply by another square root of 5y to get rid of the radical. So what my answer is going to be is, we're going to have, the numerator is going to be 2x times the square root of 10x, y. And our denominator is going to be 3y squared times 5y. Just keep in mind this is a 5y. So 3 times 5 would be 15. Y squared times y would be y to the third. Okay, and then our final one is going to be taking the cubed root. So we've got the cubed root of p to the third, the cubed root of p squared, the cubed root of q to the third, and hoping that you know that the cubed root of 8 is something we can take. So we'd have the cubed root of 8 times the cubed root of 5. So in our numerator, 3 divided by 3 would be 1, so we would have p, and we would also have q, and we'd have cubed root of p squared. In our denominator, we're going to have 2 cubed root of 5. Now since it's cubed root, we're going to need 3 of these, so we're going to need to multiply by 2 more of them to give us a 5 that we can use in the denominator. So I'm going to put 2 more in the numerator and in the denominator. Cubed root of 5. So what that's going to leave us with, the numerator will be p cubed to the third times the square root of 25, I'm multiplying the 5's together, p squared, over, now the denominator, I've got 3 cubed roots of 5, so that's 5, times 2 would be 10. Okay, don't let yourself get frustrated with these. Just let me know if you need help. The key might be to break them down into prime factors. Give them a shot, let me know if I can help, and then I'll see y'all next time. Have a good day.